Hello students and welcome back. So now we are going to talk about that how can we implement a function using a given decoder. So in this video we are going to talk about that how can we generate minterms using a decoder and implement any function using the given decoder. Decoder has special feature. We can also implement more than one function using a single decoder. So now let us get started. So here, first of all, when we look at the decoder, we have 2 inputs and 4 outputs for a 2 to 4 decoder. Now we look at the truth table and we observe that the Boolean expression for y0 is b bar dot a bar. For y1 it is b bar dot a, y2 is b dot a bar and y3 is b dot a. These are nothing but 4 minterms. That means using a decoder I am able to generate the minterms. If there are 2 inputs, I can generate 4 minterms. If there are 3 inputs, I can generate 8 minterms, and that means using a 2 input decoder I can implement any 2 input function. How can we do that? Well, let us see. We can assume that any Boolean function is a sum of minterm. It is also a product of maxterm, but we had discussed it that any function can be represented as sum of minterms. And what is sum? Sum is logical OR. That means if a decoder that is generating all the minterms for a n variable function, we can simply use OR gate. Wherever the output is 1, take the OR of those outputs and we can generate the desired function. Now, how do we do that? Let us have one example. We are saying if I have inputs x and y, I am generating these 4 minterms m0 to m3. I am given a function which is a function of 2 variables and the value is 0, 1, 1, 0. Now, we are going to take 1, 2 to 4 decoder and look at the truth table. Wherever the value of f is 1, take those outputs. These can be 2, 3, multiple of them. Take all of them, connect with one OR gate, and the output of OR gate is our function f. So this is the simple implementation process using a decoder. Let us cross check whether it is working or not. So we have E equal to 1 all the times. That means the decoder is working normally. Then A and B, these are the 2 inputs. A is at higher priority, B is at lower priority, or you can design accordingly. Here B is higher, A is lower. So B is higher, A is lower. Fine. Now if I give 0 and 0, that means y0 will be 1 and all others will be 0. So what is going to be the output of OR gate? 0 or 0. That means 0. When I give 0, 1, 0 and 1, y1 will be high. So here, now this is high. This is still low. This one is also low and this is anyways low. But the OR of 1 and 0, then the f is becoming 1 and I get f equal to 1. Then if I try 1, 0, y2 is going to be 1 and because of that f will be 1. And for 1, 1, y3 is going to be 1. In that case, y1 and y2 both are 0, output will be 0. So effectively, this complete circuit will work like XOR gate. This is the function of XOR gate. So first of all, I have a look at the 3 to 8 decoder that I had already designed. There are 3 inputs ABC, 8 outputs y0 to y7 and 1 input is E. This is the order and I remember this order. and then I come to my new source, which is function implementation using decoder. Here I have enable 3 inputs ABC and only one output Y. Now what I am going to do, all the outputs of the decoder, I will connect them with some wires. So I declare 8 wires, D0 to D7, and now let us connect it. The module name for our decoder is decoder 328. Then I instantiate, and the first 3 variables were ABC, so I connect ABC in the same sequence. Then 8 variables were the output variable, so these 8 wires I connect here, and finally it was enable. So now I have my decoder brought into this source. I don't need to connect all the output wires. I will focus only on D0, D2 and D4. So I simply say assign Y is equal to D0 or D2 or D4. Now, if someone asks you, can you please implement one more function which is summation of 1, 3, 5? We can very easily do that. We will have one more output variable, maybe Y2, and we will say Y2 is OR of D1, D3 and D5, and we can have more output functions coming out from a single decoder as well. It can be very easily done. As of now, let us see that what is the schematic for this implementation. So we can observe enable is connected to enable, ABC to ABC, and there are supposed to be 8 output variables, but we have connected only 3 of them. We have taken OR, and that is our output Y. Now we are going to simulate and check if it is actually working like the given function. So here I have kept enable equal to 1 all the times. Then ABC I have given them as clock signals. So I generate all the 8 cases. These are the internal signals D0 to D7, and you can see they are following the pattern of a decoder. But my focus is on Y. Y is 1 for 0, 0, 0, and then 0, 1, 0 and 1, 0, 0. That means 0, 2, 4, 0, 2, 4, and it repeats. So that is how we have implemented one function. You can include more and observe that they will also work perfectly fine. So students, now we have seen a few combinational modules. In the next one, we are going to start discussion on code converters. We are going to talk about binary to gray converter in our next video. Keep learning. Thank you.